All right, today we're going to be looking at worksheets 3, 4, 5, and we're going to glance at 6. On 3, all I was going to do is warm up today with a problem. Or 2, does someone want to pick one that went ahead? Because I had suggested to you on Friday that if you wanted to get ahead, you could start working on worksheet 3. Anyone have one they want to pick? Or somebody just spotting one within worksheet 3, A or B, both either side, because that's the sign. It's going to be an assignment. You want me to just pick one and do one? All right, since no one's asking or picking one, I'll just pick one. Oh, thank you. All righty. 10. Okay, 10. All righty. We'll distribute 3/4 first, not that you have to. There is the option of canceling out by multiplying both sides by 4, but then you'd still have a fraction in the problem. Okay, so this is a way to do it right now, just distribute. And I'd like to remind you of how to multiply fractions anyway. When you multiply a fraction times a fraction, you do numerator times numerator, denominator times denominator. So this would be 12/20 times x minus. Now, when you have a whole number and you multiply it by a fraction, you want to think of that whole number as a fraction 2/1. And you multiply numerator times numerator, 6 over denominator times denominator, which would be 4. And then you have equals 11/4. Now, this problem, you could add 6/4 to both sides. I'm going to clear the fractions because I'm wanting you to get used to that method so you don't have to deal with them anymore. So we're actually going to multiply by the LCD 20. And not that we could have reduced this and then taken care of it, but this will work just fine. So I'm multiplying by 20 for each piece. So I'm going to show that, of course, 20 goes out with 20. We get 12 times x minus, I'm going to cancel out 4 goes into 20 5 times. 5 times 6 would be 30. 4 goes into 20 5 times. 11 times 5 is 55. I think we did this problem before. I feel like we did in our notes, to be honest with you. Oh, bless you. Then you would add 30 to both sides and divide by 12, and your answer would be 85/12. Okay, we want to do one more from worksheet 3, A, side A or B. Someone want to pick one? I'll do it. Esmeralda? 19. All righty, let's go. I don't want to keep saying alrighty today, but anyway, we'll multiply through by 1/3. So that'll be 1/3 x, or x over 3 would work too, minus, and then I'm going to do 1/3 times 6, which would be 6 over 3. If you think of it like that. Okay, equals -2/5 x plus 14/15. Okay, now I'm going to clear the fractions. I look at all the denominators. 3 times 5 is 15, so that would be your LCD. Every number in the denominators would divide evenly into 15. So that would be the easiest. So I'm going to write 15 in front of each of these. Okay. 3 goes into 15 5 times, so that would be 5 times 1x, which is 5x. 3 goes into 15 5 times, so I got minus 5 times 6, 30. 15 divided by 5 would be 3. 3 times -2x would be -6x. Plus, 15's cancel out here, 14. You just got to remember to multiply every term by the LCD. Now we're going to combine get our variables on one side. I'm going to add 6x in my head. Some of you might do 2 steps right now. I'm going to add 30 now. 44, and divide by 11 and get x is 4. Okay, that worksheet needs to be completed as an assignment. Okay, moving to worksheet 4A. Translating and solving for a variable. This is all more, by the way, all that we've done so far is one section in your textbook, but we're spreading it out. Okay, that's almost all of this whole stuff is up to the first quiz, is the first section, or section 1.3. All of these topics, all of these that little chart you've got there, the sum, plus, added to, increased by, all of those are different, augment, combined, means to add. Whole bunch of words here that you can have in word problems that indicate that you should subtract. It's a list. Multiply, which is product. That's probably the word that we need to make sure we get straight, product. And quotient is division. Ratio would indicate division. And then words that indicate equals, an equal sign in a word problem. These are just some ideas what that could be. And then, of course, the unknown or variable is your variables. The big important thing to note down here is making sure that subtraction is in the proper order. I'm going to be real nitpicky how we write these right now because subtraction has to be in the right order, else it's totally wrong. Addition, you can add any direction you want. It's going to give you the same result. But subtraction, it has to be one way and only one way. So 8 less than a number x is not starting with the 8. 8 less than something. It means you're taking away. This means subtract 8 less, and you're taking away from x. So it has to be x minus 8. While 8 minus the number x is 8 minus x. There's a big difference. You have to know how to read it carefully. So 5 more than a number n. I'm going to be technical about it. I am not going to write 5 plus n because it says 5 more, which means to add 5. And what are you adding 5 to? N. So it really, the literal meaning of what this says is n plus 5. A number, now I wouldn't have marked it wrong if someone had 5 plus n because it's still accurate. Okay, it's subtraction, that's really important. All right, a number n divided by 5 would be n divided by 5. I really don't want to see you writing this. Okay, let's write a fraction. It's not that it's wrong, it's just I want to see this. All right, 5 less than a number n. Now that matters. 5 less means to subtract 5. What are you subtracting it from? N. So it is n minus 5. The sum means to add. The sum of a number n and 5 would just be n plus 5. Okay, the product. Product means to multiply. A lot of kids don't really remember that. So the product of a number, n and 3. Now you can write n times 3, but what do we like to see? Usually in algebra, we don't write it like that. We write 3n. Okay. 6, 4 times the number n plus 3. So that's it's pretty straightforward. It says 4 times, which is multiply, n, and then add on 3 plus 3. 4n plus 3. 3 times the number n minus 7. Well, real straightforward, 3n minus 7. Okay, now, does anybody want to tackle number 8? The sum of volunteer for the sum of 3 and n divided by 7. Regan. And how would you write? Can you kind of describe? Did you write like that? Well, that's a lot better because I'm not happy with what I wrote. Okay, 3 plus n like this. Great. Or you can have the n plus 3 in that order and then over 7. But it has to be horizontal bar if you're going to do it this way. How could you make sure somebody knew that the whole quantity 3 plus n was being divided by 7? What's another way you could make sure someone had that right? Anybody have? No? Destiny? Parentheses. Okay. Somebody else is probably about to say that. So either that, you could do this. All right, great. 3 more than the product of 7 and n. Someone want to do 9 for me? Tell me what 9 should read. Luca? 7n plus 3. And that is in literal order. Good. 10. 3 less than 5 times the number n. It has to be in a certain order. Laura? Great. 5n minus 3. The 5n must come first. The product of 8 and the sum of x and 5. Someone want to give that one a shot? Yeah, I was trying to see. All right, Trinity. 8 parentheses. Okay, x plus 5. Good. And 7 more than the product of 6 and y. What order is that indicating? That one. Okay, Luca? 6y plus 7. That's it. Yep. It's good. I mean, if you're being, I wouldn't mark you wrong again if you had 7 plus 6y, but it's saying you're supposed to add 7 to something. Okay? All right. I'm going to go a little quicker because we need to get rolling on some more stuff today. 6 increased by 4 times the square of x would be 6 is getting increased by something. You put 4 times the square of x, x to the second. 4 times x to the second. And twice the sum of 9 and x would be 2 times 9 plus x. 4 times the difference between n and 5 would be 4 times, the difference means to subtract, n minus 5. And 1/2 the square of x, x squared divided by 2, or you could write 1/2 x squared. Okay, we good? Anybody still need this? Okay, we're going to write a verbal sentence to represent each expression or equation. You can be as basic as you want here, or you can get creative as long as it actually means what this expression says. So you can just write, 3 times a number x, or 3 times x minus 5. I mean, that's fine. I guess I could have used a 3 there. This would be maybe twice the sum of n and 4. And I probably should have written FOUR, but anyway. Right, I was just making sure I'm thinking about how I'm trying to cover. All right, so this one might be half of m, half of a number, or I'm just going to write m, increased by 7. And then you'd write is 10, or is equal to 10. Right, got the idea? You guys could maybe just write 20 while I get set up for the next thing. Okay, on 4b, we're going to be solving for equations with variables, more than one variable, and then we're going to do some substituting after we do that. This is on, again, worksheet 4b. It says solve each equation for the indicated variable. We're going to solve for y, which means we're going to isolate the y. So to do so, the first step would be subtract 7x from both sides. That is a positive 7x. To get rid of it, you subtract it. We drop down the negative 3y, and that will equal 8 minus 7 times x. Now we need to get rid of the negative 3 that's multiplying y, so we undo multiplication by division. If you are going to divide by negative 3, you will not be leaving that with that answer as 8 minus 7x over negative 3, and I'll tell you why. You would never find that answer on a standardized test or in the back of your textbook if you were looking up answers to, say, odd problems. They would not leave the negative in the denominator. What they would do is change the sign of everything, and since that would turn these, change the sign of these, I could reverse these. So it would be positive 7x and minus 8 and a positive 3 on the bottom. So what I did was apply the negative sign to the numerator, and that turned things around. All right, that looks much better, doesn't it? Doesn't have all those minuses. That's why they would simplify it to that. The other way this could be written would be with the 3 under the 7s, the 7/3 x minus 8/3. So that's another way it might read, and that's if you would want it in slope-intercept form to identify the slope and the y-intercept, if you remember that. The next one's one of the simplest ones possible. You got interest is equal to principal times rate times time. That's what it stands for. We will be using simple interest formula briefly. If we're going to solve for t, p and r, what are they doing to it if they're all bunched together like that? Adding or subtracting or multiplying or dividing? Multiplying. So what can you do to get rid of multiplying stuff? Division. Divide by PR. What I don't want. So you can solve this for t and say t would equal I over p times r. Okay, I think this one is on here. Great. Yes. All right, C. We're solving for x, so we're going to get rid of the minus 9y somehow by adding 9y to both sides. Okay, so I've got 11 times x equals 9 times y minus 4. I'd like to put the y first. It could have been negative 4 plus 9y. That's not incorrect. Then I would divide everything by 11. And you can say x is equal to 9y minus 4 all over 11. Or x equals 9/11 y minus 4/11. Either one would be acceptable. Now D is tricky. And it's going to be something that most of you do not recognize right away. What we would need to do to solve for y. Y is attached to an x, and then it's also here with a negative 1 coefficient. It's in both, it's in two places. So you cannot, I can't add y because then I'll have y's on both sides. How can I isolate the y? And it's one of the F words in math. It's not fraction. Function, nope, not that one. There's another one, because then you're going to learn to be an expert at it this year, and if not, it's going to make you struggle. It's called factoring. If you don't like factoring, you better start once we get going, because we will be doing it, and it's critical to your success in the course. So, what's in common to the two terms? Y. So guys, it's really not a big deal. Do you know what you would do if you had, say, this? What would you do? What's it called? Distribute. All factoring is undistributing. All right, so I'm going to take a y out. All right, what would xy divided by y leave you with? Okay, what would y divided by y leave you with? 1, not 0, okay? Now think, when you do a factor, just double check it by seeing if you went back and multiplied this out, would you get back to what you had? And yeah, you would. Then you factored it right. Okay, now, that was called monomial factoring. We factored a monomial from the terms. Okay, now, we need to get y along. This is now a product. Anytime you have a product, you can divide by the piece you don't want. So this is what we're doing. We're dividing by x minus 1. So y equals 10 over x minus 1. And you can write it like that, or you can keep the parentheses around it. It's up to you. Not that bad, right? Okay. But by the way, one of the most missed questions on the quiz this week. Calculating the value of a variable. Well, this is asking us to find the value of y for the given x values. Okay, so first they're asking us, don't the directions tell you you're supposed to solve for y first or not? Find the value of y for the given x value first, solving for y, and then plugging in. So we're going to keep practicing that, solving for y. All right, so let's subtract 3 from both sides. So we get 2 times y equals x minus 3. Divide by 2, x minus 3 all over 2. Now I'm going to go ahead and substitute in the negative 1. So y is going to be negative 1 minus 3 over 2, which is negative 4 divided by 2, and that's negative 2. Oh, there's that one again. If I'm going to be solving for y on the problem, I'm going to factor. So this is a good example of what we just went over a moment ago. Factor out a y. We have y times x minus 1 equals -4. Divide by y minus 1. We'll have -4 over x minus 1. Now, substituting in -4 for x, we'll have -4 over -4 minus 1, which gives us -4 over -5, and that's positive 4/5. Okay? Right, did anybody still need this? Okay, move on. Equation with more than one variable. You're organizing a benefit concert, and you plan on having only 2 types of tickets, adult tickets and children's tickets. Write an equation with more than one variable that represents the revenue from the concert. Okay, so if I let A equal the number of adult tickets, where are we? This is on, is this 5? Sorry, I'm just making sure I know what. Actually, we got to talk about revenue. So we're going to need X, B, we'll go ahead and be the A for the number of adult tickets. And let's let X equal the price for that ticket. And I'll go ahead and set it adult instead of child, so I'll use a C, number of children's tickets. And I'll let Y equal the price for a child. Or price for a child would sound better than that. All right. So if revenue, or what you're going to take in, R would be the revenue. All right, so what would we do to get that? I've got a ton of variables here. So I've got price for adult ticket, A times X, plus the price, the number of children's tickets times the price, C times Y, equals what you take in. That's what you're going to be selling them for. Okay, now we're going to use an equation with more than one variable again. We're going to use this equation. For the concert example 3, your goal is to sell $25,000 in tickets. That would be the R value. You plan to charge $25.25 per adult and to sell 800 adult tickets. All right, so A, the number of adult tickets is going to be 800. X was the price of the adult ticket, which is going to be $25.25. What else we got? And we got R is 25,000. You need to determine what to charge for adult tickets. How much should you charge per child if you expect to sell the following? Okay, so we're going to be using 200 child. That would be your C, right? The number. This one's going to let C be 300. And this one's going to let the C be 400. Now our equation was AX plus CY equals, was it 25,000? Yep. Or R, that would equal, well, I guess I can pop in the numbers now. I had R in my original equation. So I'm going to put in everything I can. So 800 times 2525 plus, we don't know, are we going to, oh, we're going to put in 200 Y equals 25,000. Now, this is a constant, the 800 adult tickets. The only variable that's going to be changing for our answers is the C, not the, the price of the actual Y value. So, give me 800 times 2525, please. I think it's 20,200. Yeah. Okay, so let's get our equation simplified so we can solve this 3 times. Take in 25,000 and subtract 20,200. So C times Y is going to equal, what's 25,000 minus 20,200. I had 4,800. Is that what you got? All right. So if we're going to sell 200 child tickets, divide by 200. Is that 40? No. Duh. 24, right? Okay, so that'd be $24 if you're going to sell 200 children's tickets. So this is basically our new equation where we're plugging in different C values. So now we're going to put in 300 for C. So take 4,800 divided by 300, $16. And then the last one, 400, Y equals 48,800, and that's going to be 12. Okay. Anybody still need this? Okay, I'll move to the formula for the perimeter rectangle is perimeter is equal to 2 lengths plus 2 widths. Solve for W. Okay, P equals 2L plus 2W. I'm just rewriting the equation. I could subtract 2L from both sides. Okay, P minus 2L equals 2 times W. And then I could divide by 2. P minus 2L over 2 equals the width. Or you can have P divided by 2 minus L. Now that will be a skill also that will be valuable at some more points in the semester. Just separating these two terms is all I did. Okay, I did P over 2 and this over 2, which reduced to L. That's all I did. So either of those answers I would take on the quiz. Diego? Which one? Okay, I subtracted 3 from both sides and divided by 2, and then I popped in -1 for x. I got -4 over 2, which was -2. Is that what you needed? Okay. All right, we need some more practice possibly on this. This is 5A. Find the value of y for the given value of x by first solving for y and then substituting the value of x into the equation. We did not do this, right? So familiar. It's just like what was on 4. No. I didn't already go over these. Okay. That's the first solve for y. And I already did that on another problem, not that you have to. I understand that a lot of you just want to go and stick 5 in there and then solve. But it's specifically saying to first solve for y. So I'm going to subtract 3x. So 2y equals 1 minus 3 times x. Divide by 2. Just like you would if you were solving and getting just an answer. We're just doing the algebra steps, undoing things to get down to what we want. Now I'm going to pop in 5. Substitute 5 for x. Would be 1 minus 15, which is -14 divided by 2. So our answer is -7. Number 2, our third one today, where we need to factor. I'm factoring out a y. xy divided by y is x. Minus 2y divided by y would be 2. Equals 12. I need to get y alone, so I'm dividing by x minus 2. Next, I'm substituting in the value of x is 3. 12 over 3 minus 2. 3 minus 2 is 1, and that means that y is just 12. Now, clearly, I hope you're realizing I expect you to know algebra steps pretty fast, like if we were doing a full solve, but now we're applying it to solving for variables. Okay, we're supposed to solve for y first, so all I'm going to need to do is subtract 1/2 x. You can either write negative 1/2 x plus 1 or 1 plus 1, minus 1/2 x. Sorry about that. Same thing. I don't really care which way you write it. Okay, when we substitute in negative 8, 1 minus, if you want to do it that way, half of negative, oh, it's not an 8, it's a negative 6. My blind eyes. Well, they're not blind, they're just not good. All right, 1, that'll be 1 plus half of 6 is 3. 1 plus 3 is 4. Negative times a negative positive. Good? Okay, here's to the nitty-gritty. These are super, super easy questions. Distance is equal to rate times time. That's the formula. We want to solve it for t. We need to get rid of r, which is multiplying t, so we divide both sides by r. So I'm hoping this will be your simple problems right here. Time equals distance divided by the rate. You don't have to know what all the formulas mean. I'm just going to go ahead and say it if I recognize one. Interest equals principal times rate times time. We will use the simple interest formula at some point. R and t are multiplying the p, so we'll divide by r and t on both sides, and then just write that p equals I divided by r times time. Rate times time. Okay, 6. Now we get a little harder. Do you recognize that formula? Geometry. What is the formula for? Area of a what? Trapezoid. Yep. Should be familiar. Okay, so I want to get rid of that too. It's dividing h. So we're going to do the opposite of divide. Multiply. All right, so we got 2a equals, the 2's by the h would cancel, h times base 1 plus base 2 in parentheses. You want h alone. H is multiplying this big blob, b1 plus b2. So just get rid of it by division. Divide by the quantity b1 plus b2. Okay, so h, now alone, equals 2a all over base 1 plus base 2 quantity. I know this bugs kids. You're gotta try to get used to it. I know I make it look easy, and then when you go do it by yourself, it's a little bit harder. But hang in there. You're gonna have some practice to do. Obviously, I've given you quite a bit. I want to start for big R on this one. Do you want to distribute, or should we just get rid of pi first? Yeah, that would be simpler. Divide by pi. Okay, so we got s over pi equals, it's not wrong if you distribute though, it can show both. Cap big R plus little r. All right, now if I want r alone, all I got to do is get rid of the little buddy, little r, by subtraction. Okay, so r, if you want to write it r first, big R is equal to s over pi minus r. If someone had distributed, I will show what the answer would have been. It would be s minus pi r, and then you would have had to divide by pi. This answer is satisfactory as well in case somebody went ahead and did that. It's equivalent. You can see it's equivalent because there's s over pi, and this would have canceled, giving you the minus r. Solve the formula for the indicated variable, then evaluate the rewritten formula for the given value, include a label. P equals 4s, solve for s, so that'd be p divided by 4. If p is 44, it's just 44 divided by 4 for the length of a side, and that would be 11 centimeters. Area is length times width. Solve for L. You would divide by W. A over W would equal L. If the area is 2 square feet and the width is 8 feet, to get the length, I'll show you the dimensional analysis. Feet would cancel out with one of the feet on top. 2 goes into 2 once and into 8 4 times, so the answer would be 1/4 of a foot. Okay, that was 5A, correct? These few, and then your assignment is on the 6A, and the book page I did type up, or not type up, but I made you the worksheet, so you've already got that. Sometimes it's helpful in real life problems to write an equation in words before you write it in math symbols. Okay. Of course, assign labels. That would be like, what is your X? Okay. That's your question, or how many it is, or what. Write your algebraic model. You're going to solve it, and then when you answer the question, it should be a really brief sentence with labels. You own a lawn care business. You want to know how much money you are spending on gasoline to travel to clients. In a typical week, you drive 600 miles and use 40 gallons of gasoline. Well, that's a clue right there. You can use 40 gallons, right? Do you really care how many miles you went? Not really. There might be extra information. And I want to determine again, what is the question? You want to know how much money you're spending on gas. Did it say per client? It didn't really say that. So it says gas is $1.25 a gallon and your truck's fuel efficiency is 21 miles per gallon on the highway and 13 miles per gallon in town. Well, if I needed to know, like, okay, who's living in town and how much am I spending on them, then I could make a more complicated equation. We could do it, and we could figure out how much it costs to go to which per gallon, but I don't know. I don't really see any need to do all that stuff, because all it said was, how much money are you spending on gas? Well, you're getting 40 gallons at $1.25 a gallon. Isn't that pretty straightforward? So I'm thinking, let's just do 40 times $1.25. All right, so is that $50? Okay, now, could we figure out more information? Yes, we probably could, but we're not going to. We're going to move on because that's really what the question asks. How much are you spending on gas? All right, now this one, we got a little more thinking. We got a table, gives the heights to the tops of the first 2 stories of a tall building. Do you see any constant increase in here? Start looking at these numbers. But this is like the lobby, it doesn't count as one of the stories. But you got to include your lobby, don't you, on your building? So it's like you got your lobby, which is all fancy and 20 feet tall, and then the floors are just 12. Okay, so that's 12, that's 12, that's 20. So sometimes a model can help you think of your equation too. And we're just going to go up to the 15th story. But I don't want to just keep adding on 12, do you? And go out to 15? So let's write an equation. So the height of the building, what's it determined by? You've got the lobby, all right, which is 20 feet tall, plus how much is it for each story? All right, 12. So if X equals the number of stories, then we would have to do 12 times X to get the height of that building. But we also have to include the lobby, which is the 20. All right, so we're going to plug in 15 now. 20 plus 12 times 15. I'm sorry? No, because it's not the same height. Okay? That's why I drew the picture, because I was making you think about, you got your lobby that's 20 feet tall, and then you start adding on 12 foot per story. They're not calling the lobby a story, so we had to make it like stories or 0. So we have to include it though in the height of the building. So I forgot what this came out to. 200 feet, because you got to make sure you include that 20, guys. All right, so it is 200 feet tall. 200 feet to 15th floor. I don't know if it has more floors. All right, we'll wrap this one up. I'll do it quick tomorrow so you guys can get packed up. Have a great evening, and don't forget to work on 6A and page 22. Oh no, 3AB and 6A. Don't worry about page 22 necessarily till tomorrow unless you've got time. Okay, and you know you don't have time tomorrow.